So in trigonometric equations, we have different methods now. 3-4 special methods are there. For example, we can solve trigonometric equations by factorization method. We can solve equations if they are convertible to quadratics. So in quadratic form also we can solve. Some equations can be solved by introducing some auxiliary argument. That means equations of the form a cos theta plus b sin theta is equal to c. Equations can be solved by extremum value conditions or boundary value conditions. They are very special type of equations, and there are certain trigonometric equations which are mix of trigonometry plus algebraic part, which can be solved by graphs also. So there will be different approaches of solving trigonometric equations. So let us start with the factorization method. In this, the idea is we can factorize. We have to take the common factors outside. So some questions I have taken here to introduce this concept, how to apply this concept. For example, question number 1, 2 sin x minus cos x into 1 plus cos x is equal to sin square x. So immediately for solving this problem, immediate idea comes that this sin square x must be written as 1 minus cos square x. So in question number 1, we can write 2 sin x minus cos x into 1 plus cos x is equal to sin square x. Sin square x can be written as 1 minus cos square x, and this can be written as 1 minus cos x into 1 plus cos x. So we can factorize it 1 minus cos x into 1 plus cos x. Now important thing, don't cancel this 1 plus cos x, this 1 plus cos x. This is because this is one of the root. This can be taken outside. So we can write in this form, if 1 plus cos x, if I take outside, what is left from here? 2 sin x minus cos x, and this term will come this side, minus 1 plus cos x is equal to 0. This term will come this side, and this factor is common. So minus will come here, minus 1 plus cos x is equal to 0. So this cos x will cancel out. So from here we can have either cos x is equal to minus 1 or sin x is equal to half. And their solutions we can easily write cos x is equal to minus 1, that means x is equal to pi or 3 pi. So 2n plus 1 odd multiple of pi. So x is equal to 2n plus 1 into pi, or sin x is equal to half. So x is equal to pi by 6, or x is equal to k pi plus minus 1 raised to power k into pi by 6, where n and k belongs to set of integers. N and k belongs to set of integers. This will be solution of this equation. Question number 2 is 1 upon sin square x minus 1 upon cos square x minus 1 upon tan square x minus 1 upon cot square x minus 1 upon sec square x minus 1 upon cosec square x is equal to 3. So convert this in 1 upon sin square x can be written as cosec square x minus 1 upon cos square x is sec square x minus cot square x minus tan square x minus sin cos square x minus Sin square x is equal to minus 3. We can write this in this form. Now, cosec square x minus cot square x is equal to 1. Sec square x, this we have to convert in tan form. So this equation can be written as, using our simple identity, sin square x plus cos square x is 1. So cot square x, cosec square x minus cot square x is 1. This is minus 1, so they will cancel out. So we will have 1 minus sec square x minus tan square x minus 1 is equal to minus 3. So this 1 will cancel out this 1. So now you can write sec square x is equal to 1 plus tan square x. Minus minus will cancel. So this gives you sec square x plus tan square x is equal to 3. Sec square x is equal to 1 plus tan square x. So 1 plus tan square x plus tan square x is equal to 3. Or 2 tan square x is equal to 2, or tan square x is equal to 1. So from here you are getting this is equivalent to tan square x equal to 1. So its solution will be x is equal to n pi plus minus pi by 4. Solution of this equation. Tan square x is equal to tan square pi by 4. Question number 3. Sin cube x into 1 plus cot x plus cos cube x into 1 plus tan x is equal to cos 2x. So here the golden rule is we must try to convert everything in sin and cos. Then it can be done in a much better simplified way. So I can write this as sin square x into sin x. I am writing sin cube x in this form, sin square into sin, into 1 plus cos x upon sin x plus cos square x into cos x into 1 plus this is tan x is equal to, now cos 2x also we can write cos square x minus sin square x. So if I take LCM, I will get sin square x, sin x will cancel, cos x plus sin x plus cos square x, cos x will cancel out, cos x plus sin x is equal to, this is also in the form of a square minus b square, so cos x plus sin x into cos x minus sin x. In this form we can write. Now you can see this cos x plus sin x we can take common. So cos x plus sin x is common. Remember, this we are not supposed to cancel. If we are cancelling it, we are losing one vital root of the equation. So this sin square x is left plus cos square x, and this term will come this side, so it will become minus cos x plus sin x is equal to 0. So from here we will get sin x plus cos x plus sin x is equal to 0, or tan x cos x equal to minus sin x, or tan x equal to minus 1. Cos x equal to minus sin x. So this will give cos x is equal to minus sin x. So tan x is equal to minus 1. In this form we can get, this is 1. So we will get from here 1 is equal to cos x minus sin x. So cos x minus sin x is equal to 1. Divide by under root 2, cos x minus sin x equal to 1. This we can simplify. There are different ways are there. 1 minus cos x is 2 sin square x by 2. Two methods. If you want to solve in that way, you can write this 1 minus cos x plus sin x is equal to 0. Then 1 minus cos x, this implies that 1 minus cos x is 2 sin square x by 2 plus 2 sin x by 2 cos x by 2 is equal to 0. 2 sin x by 2 you can take common. If you take 2 sin x by 2 common, 2 sin x by 2 is outside. What is left? Sin x by 2 plus cos x by 2 is equal to 0. So this is exactly similar problem. So we will have from here sin x by 2 is equal to 0. This gives that sin x by 2 is equal to 0 and tan x by 2 is equal to minus 1. Tan x by 2 is equal to minus 1. When tan x is equal to minus 1, one solution is minus pi by 4 or 3 pi by 4. So x is equal to n pi plus, this is like a pi minus pi by 4, 3 pi by 4 if we want to write principal solution. From here you will get x by 2 is equal to n pi. X by 2 is equal to n pi. This will give x by 2 is equal to n pi. Or from here x by 2 is equal to n pi plus 3 pi by 4. Now you can write this question in this form. So x is equal to 2n pi. X is equal to 2n pi. X is equal to n pi plus 3 pi by 4. And x is equal to 2n pi plus 3 pi by 2. Now one important thing here, we must see the domain of these questions also, whether they are within the domain or not. For example, when tan x is there, then x cannot be odd multiple of pi by 2. And here I am getting this odd multiple of pi by 2, 3 pi by 2. So this solution I have to reject because at these values tan x will not be defined. So this is not a solution of this. Why? Because it is outside the domain. X will not be defined at 3 pi by 2. Similarly, cot x. Cot x is not defined whenever sin x is 0. So sin x will be 0 at these points, 2n pi. So this is also cannot be solution of this. This also I have to reject because it is not in the domain of cot x. So these two solutions I have to reject. So this is the only answer of this. X equal to n pi plus 3 pi by 4 is the only answer of this question. X equal to n pi plus 3 pi by 4. Next, this problem. Log 2 sin x into 1 plus cos x is equal to 2. We have to find its solutions when x varies between 0 to 2 pi. Now, whenever log is there, again see what are the conditions. Sin x must be positive. So, we will not have any solution in the third and fourth quadrant. Sin x at the same time, x cannot be 0 or pi or 2 pi, x cannot be pi by 2, 3 pi by 2 or any of those things. And under root 2 sin x, 1 plus cos x is equal to, so now we can write 1 plus cos x is equal to under root 2 sin x whole square. So this is equal to 2 sin square x. So this again we can write 2 sin square x as 1 minus cos square x and simplify. Or 1 plus cos x factorization method we can use, any method, because I can write this as 1 plus cos x is equal to 2. Cos square x is sin square x is 1 minus cos square x, that is 1 minus cos x into 1 plus cos x. Now take 1 plus cos x common. So 1 plus cos x common. What is left? 2 minus 2 cos x, and this term will go this side. I am transferring all this term this side, minus 1 is equal to 0. So from here I will get, this will give me cos x is equal to minus 1, which is not possible because cos x is equal to minus 1, x will be pi, at this it will not be defined. So this is rejected, this I will reject. So next is left 1 is equal to 2 cos x, cos x is equal to half. 1 is equal to 2 cos x is equal to half. This solution only we will retain. So x is equal to half, means pi by 3. And 2 pi minus pi by 3. So pi by 3 and 5 pi by 3, these are two solutions of this equation. So in this way we can solve. The most important we have learnt in this video is there will be some solutions which are outside the domain. So first we must fix the domain. We must check whether at those points our tan x, cot x, sec x or log base, all these things are defined or not. For example, in this case we got two solutions, x equal to 2n pi and x equal to 2n pi plus 3 pi by 2. But at 3 pi by 2 we have seen tan x is not defined, odd multiple of pi by 2, and at 2n pi cot will not be defined. So we are rejecting these two solutions. This was having only one solution. Similarly in this case, base sin x. So sin x can never be negative, sin x can never be 1 or minus 1, those things. So here we got one solution, cos x equal to minus 1. It's one of the solution, cos x equal to minus 1 is pi. But when I put here sin pi, 0, it is not defined. That is why I rejected that solution. So this equation is having only two solutions, x equal to pi by 3 and 5 pi by 3. This is 6 minus pi by 3 is equal to 5 pi by 3.